So today's lecture is about the data visualization, actually, the basic principles of them. And I thought I'll start with the wind roses, because nearly all of you have done this in your design project. And I guess you've seen this in the email already. But do you agree with me that by looking at this three chart, you wouldn't be able to tell that this is actually the same data? At least the very first one looks very different to the other two. The one in the middle is so complex, it's a little difficult to interpret on the first sight. But if you compare the first one and the last one, the first one is clearly, the wind direction is dominated by the west and southwest. And on the right-hand side, you can still see there are probably more frequently the wind come from the west, southwest, but it's nothing as dominating as this one, right? Now, how can this happen? Because these two charts, the original data, the weather data, are exactly the same. The only difference is how the chart is plotted, right? So this actually tells us the way you present data visually has a big impact on what information your user, your audience is getting. So that's what we are going to talk about today. Now let's talk about the wind roses. Now the 5 of them, I got it from your portfolio. And they all follow the kind of same principle. They all belongs to the same category as this one. This is actually the officially recommended by NOAA. And this is what a wind rose chart should look like. So the slight difference is this one has more directions, and in the charts you have used, there are 16 directions essentially, and this one has more. Can't tell how many. So 32, something like that, I think. But they're presented in essentially the same way. I hope you all know how to read this. So the wind speed is color coded. So if you see the legend, say 2 to 5 meters per second, no, that's mile per hour actually. And this one varies, and different charts probably have different units. So this is a meter per second. So this one is mile per hour, and this one is a kilometer per hour. So that may there are some differences, but essentially it's the same. So the color coding is for the wind speed. The direction is obviously the wind direction, and then the length of the bars are the frequency, either in the form of hour count, number of hours, or a percentage point, right? So this one says something like 8% of all hours throughout the year that wind will come from this direction, and for each speed category, that's above 20 mile per hour. It's I don't know, 0.4% of time that have this kind of speed at that direction, from that direction, right? So this is how this wind rose is read. Now, let me first talk about the presentation. So the information delivered and the form of it is identical, but there's some small difference in the way it's presented. This diagram comes from Mike Fortham, actually. And it's a lovely design. And one thing he did particularly well is actually overlaying the wind rose on top of the building. this make it very easy to see in relation to the building itself where the wind comes from, rather than just north and south. But it does cause a potential issue, because when you overlay that chart on top of a building, it implies that the data is coming from that particular location, which is cannot be the true. It cannot be true, because all this weather data comes from either an airport or somewhere where there is a weather station. So it's not exactly located here. So the wind condition near your building can be a little bit, maybe quite different to where your weather station is. But by overlaying it on top of a building, you are implying that this applies strictly to your building. This can be an issue, but it's not a very important one. I think I'm just saying you should be aware of that. So you can very safely overlay the sun path over your building, because that will be strictly applicable to your particular location. But for weather data is kind of different, right? This too just differs in color coding, so no. But I think this actually come from different weather stations. So this is a city airport. This one is probably Gatwick. You can see the direction is slightly different.
Yi.
Yep.
Sorry. I was thinking about what you were saying about how the windrows isn't exactly on top of the site, so it shouldn't really be placed on top of the site in terms of like a drawing. But isn't it accepted that since we can't actually get the windrows on top of our site, we're just going to assume that it's the same as the weather station, and therefore,
yes,
in terms of the project, it's just going to be the same.
That's right. So that's the only way you justify it. Say this is what I assume that this will be the wind condition. Now, I'm not saying this is important, but you need to be aware that when you're drawing it like that, because we are talking about visually presenting something, and the way you present things has certain meaning in it. And when you overlay a windrows on top of building, it would imply you are telling your reader that this one applies to there. Now, you need to have the confidence to say that. You need to be aware that you are actually telling your audience this is the case. As long as you can defend that, say, okay, this is the weather condition I can get, and I will assume that this applies to my building in exactly this form. That's fine. I'm just saying you need to be aware that this is what you're saying to your to the audience.
No, but if you're putting windrows into your portfolio, doesn't that already mean that you're assuming that this site has this characteristic?
If you put it as such, no one will. You are in this way. You are saying the wind condition will apply to your site, but it's not the same as you put it here, as if they were measured on site. You see the subtle difference. If you put it aside, they will still know that you are going to use this weather data for your site, but it doesn't suggest this actually coming from your site. So it's fairly subtle difference. So I won't pick you on this. I mean, this is I still think if you can get data like that, that'd be ideal. That'd be great. And presentation wise, it's very nice. It gives more information about how the wind condition in relation to the building than in this way, than doing it separately. But there is a potential drawback. There's in certain circumstances, it may cause confusion. Right.
I see.
Okay. Yeah. So what we are talking today is about general principles and the way to think rather than which one is right and which one is wrong. As long as you're aware of it and you know how to make your own choice, that's the important thing, right? Okay, right. Now we also saw some 3D diagram of the windrows. This one, well, it has the problem of the 3D diagram because the view is skewed. You don't actually get the same sense of distribution as a plane view in this one, right? And especially this one has rotated the axis a bit, making it even harder to read. I guess the reason to do that is try to avoid those big blocks hiding the ones behind. So it actually aligned the biggest one facing the viewer. So if it is sideways, then the one behind may be further obscured. But in any case, this is not adding any more information than the color-coded 2D chart, but instead adding processing load for your viewer. This one is the same principle, but the blocks are now see-through, so I get rid of some of the problems that the front blocks obscuring the behind ones. But on the other hand, it makes it even harder to read, isn't it? you can't easily pick a one element and see what the number is, what size is. So I would say, if you don't have to use 3D charts, then don't. Not just for the sake of novelty. That's say a novel chart is not always a good idea because a familiar chart, people knows how to read it. But if it is a new chart type, they have to think extra hard in order to get the same amount of information out of it. So that add more load to your viewer. So that's what I'm saying. I'll come back to that a little bit later. So let me come out, hide it. So let me go to the next one. Oh yeah, well yeah, we are going to talk about that. So when you comparing the three different charts, well, clearly from this one in London, the dominating, the prevalent wind direction is west-southwest. If you look at this chart, it's probably, I don't know, it's, wind only come from that direction, except a few hours coming from east. That's what you get. That's your immediate impression by looking at a chart like that, right? And this is caused by what I would call it as a polar chart visual bias. The reason for that is because the bar gets wider. So when you look at a chart, mentally you're comparing the size in terms of area of each bar rather than its length. But the information it should be delivering is the length. So only thing that matters should be the length of the bar, not the area of the bar. But when you look at it, because it's getting bigger and bigger, the longer the bar is, the more area it occupies. And the visual impression you get is the area, not the length, and that causes a big bias. The bar chart underneath is exactly the same data as in the one above, right? You still see that, say, more wind coming from this kind of directions, but nothing as dominating as you view it on a polar chart like this, right? And the most obvious example is this two. Let me see. I can draw on this. So that one and this one. Now, if you look at this chart, so this direction is about 2 times as more frequent as the next one here, but on here, I don't know, you probably want to say 3 or 4 times. So it amplifies the difference quite dramatically, and that leads to a very wrong impression of what actual distribution is. Okay, are you happy with that? I mean, do you get what I'm saying? Okay.
Yeah, yeah.
So do you think like a chart that looks more like a sea urchin would be better?
Like sea urchin would be better. Like using lines rather than pie sectors.
Pie slices.
Yeah, that'll be true. And if you look at this chart, this one is a little difficult to read because I encoded so much information in there. But they have actually the measures to counteract this fan out effect. For those who don't use this very often, so the center bit, well, there's a legend to tell you how to read it. So the inner triangle shows the mean, average, and the max wind speed. The outer area, this bit showing the frequency. So this bit is the same information you get from the length of those columns, right? And from this chart, you don't get the same impression as that, right? It does. Wind does more frequently coming from west, southwest, and a bit from east, which is true, but it's nothing as dramatic as this one here, right? And they did something rather clever here. First, the height of the bar is fairly small comparing to that, so this effect is not that this finding out effect is not as prominent. And also, they deliberately counteract that effect by making the top narrower than the base. So this must be, you know, in the ideal world, the size of the area should be proportional to the frequency rather than the height, because that's what you see when you're plotting an area. But that'll be quite complex mathematics to do, and so I think it's still doing the length, but they narrow the top a bit in order to counteract with that effect. So that has been done fairly well. And the speed is plotted on a separate axis, and you can easily read. It's much easier to read than using color coding, right? You can see the top speed, you can see the average speed, and from this chart you can actually say London is well, wind can come from any direction, and maybe a little more frequently from those. But it can come from any direction, any speed, up to the average wind speed is something like 5, 4. I don't know. Can't read inside now, I think. Right. So one problem I have with this chart is it's too complex. You have to stare at it for, I don't know, 3 minutes in order to understand what it's telling you, because there's so much information in there. Now, there is a use for that. So if you say during your crate, during 10 minutes presentation, you probably don't want to show this to your client. You have to leave them on screen and explain what each one is in order for them to get what you're trying to say. And that's not good. But if it is on paper, if it is in a report, when your reader have time to study it, then it becomes very interesting, because it contains a lot of information, very condensed, very informative. So that's great. Now, this chart, so instead of showing the length of the bar, no, instead of showing frequency as the length of the bars, this one shows the speed, the average speed as the length of the bar, but using color coding for frequency. This one is color coding for speed and the length for frequency. This one is length for speed and color coding for frequency. So if you look at that, it kind of tell you the same story as this. So wind can come from all directions, and the average is something like 5 meters per second. There isn't a unit showing there, but average is below 5, let's say. And then the frequency-wise, none of the particular directions will go beyond 0.2, I would say. It's not easy to read the shade of red here, so to map onto the scale, but you do get a sense that there is a slight difference. There is a difference in distribution, but not as dramatic as this, right? This chart, the problem with it is too simple. It hides a lot of information. This one at least shows the maximum, minimum, and the mean velocity. This one shows you only the mean velocity, and the frequency itself is quite difficult to read for the exact number. So to me, the best solution for wind rows is actually this one here. Can you work out how to read this? Think about what's on the length, what's on the radius of this diagram, and what's on the color coding. Well, if you look at the scale here, the color coding is for frequency, and the length, the radius is wind speed, right? But what it did is actually using a heat map. This particular chart is called a heat map, using a heat map to show where the frequency and the speed of wind and also direction, the angle is direction, so that's not a problem, where they come from, right? And you can see, okay, actually it's more frequent to have wind coming from this west-southwest direction and at that particular speed. This is very useful for building design because when you're talking about wind, it's neither the maximum speed or mean or average that's useful. It's actually the range that is useful. You can use it for example, wind power generation. Then the wind turbine will only operate within certain wind range. So neither the peaks nor the basis of interest. It's actually a ring over there that is interesting. And then with that, you can pick which direction you want your wind turbine to face. And if you talk about natural ventilation, it's the same. Say, if the wind is blowing hard, you don't want to open windows. So you have a line to say, okay, above that, I'm actually not interested in it. So this is, I think this will be the best way to show the wind rows, right?